Good morning. Good morning. You're welcome to today's lecture on the course B253. Mama, come. All right. BD253 pharmaceutical calculations. In our last lecture, we stopped at where? Where did we stop in our last lecture? Huh? Percentage, okay. I think we solved some questions there, right? And we solved a question that links common fraction, decimal fraction, and percentage. So if you're given a question where you need to calculate, express it as the answer as the decimal fraction, common fraction, and percentage, you can do that. I believe you can. I know what you can do. Now, today we go over to exponential notation. Exponential notation. You can call it exponential notation or scientific notation or standard or form, anyone. Scientific notation, standard notation or standard form, as case. That about the same thing. They're talking about the same thing. Okay. So here, in this notation, we see the application of this decimal movement in full force. Okay, we'll see the application of this decimal movement in full force. So we will define and explain what scientific notation is and how it is represented. Then we go back to the operations in scientific notation: addition, subtraction, division, multiplication. I think that's it. That's what you take on this exponential notation. So sometimes some physical or chemical measurements may be very large, too large, or very small. Maybe sometimes you see some measurement, they may be other physical measurement or chemical measurement, they may be too large. That's so then you may start writing them here. If you want to express them the way normal numbers should be, they can start from here and get to this place and stay counting. So what do you now do? You can express them as what? Exponential notation. If they tell you that what is the mass of electron? Well, what is the mass of electron? Is what? Is what? Ada? Tell us the mass of you should know it. So don't get me like that. Tell me. Tell us what mass of electron is. Fast. Is what? 9 point what? Okay, focus on the 10 raised to power what? That's what I want to hear more. 10 raised to power what? In what power? God bless you, you go far. Minus what? 31. If you want to represent whether it's 9 times 10 raised to power minus 31, if you want to represent it on this board, you keep writing 0.000000000000000 up to, right? Tell me the type of book that you will use if you want to write it like that. But you see how you now put it in this form. 9 times 3 is 4 what minus 3. Very simple. Two of us, you can represent it in that manner. Am I communicating?
Yes, sir.
So that is what this scientific notation helps us to achieve. It may be a very large number. That may even be to the power of 20 something, 28, or even 30. If you want to write it, where will you end? What type of book? What type of notebook will you use to write such a number? So that's where you can do it in this exponential form, or scientific form, or what is it called? Or standard form. I think the name you called it in your secondary school was standard form, right? Good, yeah. All right, so how do we now know? How is this number now written? How do we write this number? So one thing I want you to understand is that the exponential notation is written in a manner such that, or better still, if you see a number in the form A is power what? Minus what? Sorry, A times 3 is power what? B. Are we together? A times 3 is power what? B. Such number is said to be in what? Standard exponential notation, or what have you. Where A, or the first part, is the coefficient. So this first part is the what? Coefficient. And the second part, that is this part. The second part is the exponential factor, or power of 10. This part is the exponential factor, or simply power of 10. So if you see a number represented in this form, A times 10 to the power B, where the first part A is the coefficient, second part B is the exponential factor. Such number is said to be in exponential notation, or standard form, or scientific notation. But this A, from what we discussed in number line, this A, have you ever seen a number like this? Minus 2.0 times 0 to the power 4. Does it exist? Does it exist? I sure you don't exist. So how do you written? From your primary school till now.
I think the power without the minus sign.
Okay.
So it's not
So if I say minus 2.0 times, what I mean is actually minus 0. What? 000 what? 000 what? That's what I mean. So my question is, does this exist? Minus 2.0 times x power.
Yes.
Have you seen a number like that before? Where the coefficient has a negative sign. Both of okay. Have you seen where this one has a positive sign? The coefficient has a negative sign. You have not seen before. No, this one has no issue. I mean, negative sign here, and that number is seen in a standard form. Okay, which one this is? Tell me the one you saw. I call it.
Minus 2.8
2.8 times what?
times
Minus what? Number 3. So if this thing exists, that means this is also what? Are we together? So now, can you now tell me the range of numbers that this can be? What type of number can it be? Must it be from 0? If it's 0, everything goes now. 1 to 9, right? The one is that the integers, 3 of us, integers, right? I am arriving at somewhere. This A must be what? Integer. Am I communicating? Integer. But where will the integer start and where will it end? From what? 1 to what? 1 to 9. So are you telling me that you cannot have something like this? 20 times 3 to the power minus 4. 20 here. You can have, right? But this is not the stable form, okay? Right, it should be in such a way that the decimal point should be after the first, this what? This. So that means you can still reduce this and bring it down to what? 2.0 times what? 3 is power what? If you do decimal movement, it will go well, right? So what happened to this sign here? Will it reduce or increase? Are you sure? If this goes, listen carefully, if this goes like this, you are eating up, you are taking up something out from here, 2 of us, you are eating up a 0, right? And that's why you eat up should be, remember, hope you know that this thing is the power, right? As it eat up this, it should add something here, 2 of us. You should add something here, right? Or take something away. Because that thing eating up should be added to what? Somewhere. Because you cannot be removing and doing here at the same time. So they're opposite to each other, 2 of us. So as you eat up this 0 now, one should be added here. So if you add 1 here, it becomes what? So you have 2.0 times 8 power what? This should be the best form it can be. Are we together? Are we together? They have the same value, but if you want to place it in exponential form, it should be in this form. So that's why we had the issue of 1 to 9 came from. Am I together? Or at least you can say 1 to 9.9999 or something, because you have 9.1, 9.2, 9.3, right? 9.4. I mentioned integer. Are they really integers? Must they be integers? If it's 9.1 an integer, is 9.9 point something an integer? Is it an integer? Huh? You've forgotten the number line we discussed. It's not an integer, right? So what we said about that is the first part had to be integer. Is it correct? So simply say number from where? 1 to what? 9.9. Don't remove that integer, okay? Because 9.1 is not an integer. 9.9 is not. Just say number. It can be any what? Number. Am I communicating? Don't use integer. Okay? That's what I want to correct. Are we together? Yes. Now, this part here in the exponential factor, the power in this form now, the power has to be what? An integer. Hope you know. Yes. It's what? An integer. You know, you may have some power that will be maybe 2.1, but that one is not a standard form. Okay? All together. So you can leave it at this level. Let's not move deep. So, but the point I'm making is that the number in this form is what? A number in its exponential what? Form. A number in its what? exponential what form. If you understand, that thing we are doing here is what we call decimal movement. So decimal movement is the movement of the decimal point along the what? Along the what? The digits. Digit of the what? Of the coefficients of a what? Exponential what? Exponential form of a number, because that movement is along this what? Along the digit of this what? Coefficient. True of us. If this is a digit, right? This is a digit. It's moving along the what? Digits. So the movement, that direction of the movement is always opposite. Is opposite to the what? Is opposite to the movement on the power. If it's moving to the left, the power is increasing. True of us. So the movement, the movement is opposite to the movement of the what? The power. If it's moving in to the left, the power is what? Increasing. If it's moving to the right, the power is what? Decreasing. That's what that's what happened here now. As it's moving to the right, the power is what? Okay, now let me so if you have 2 point, let's say let's say let's say okay, 2.34 2.34 times a to the power what? 4. Are we together? Now look up. If this thing moves, if it moves from here to here, it's adding a place, right? 10, right? Are we following? So that place value that increase from 10 to, is still 10 from unit to what? 10, right? 10 is added, right? Will lead to what here? Minus 1, right? It's adding. So this one will what? Decreasing, right? So this should minus what? So this is what? 3.4 times 8 power what? 3. This thing and this thing, they have the same value, hope you know. In fact, this thing and the 2.34 times 8 power 4 and 23.4 times 8 power 3, they have the same value. Are you aware? They have the same value. They have the same value. If you move into ordinary number in its ordinary form, they have the same value. Let's check. Move this to okay. Move this to number in its ordinary value. 2 what? This one is what? They have the same value. But the one that should be the best form by looking at what a standard form is, the one in the best form is what? This one. Are we together? It's 2.34, not 23.4. Are we together? It's 2.34. I don't know if I'm making sense. So now, if you understand this, I believe if I give you a number, you can move it from index, from from exponential form to ordinary form. Or you can move a number from its ordinary form to where exponential form. I believe you can do that, right?
Yes, sir.
Good. Let me see whether it's true. Whether you can do that. Let me list some numbers. Let's see what we can do with them. Please, once is 12:25, let me know. I want to leave here at 12:30 dots. So let me list some numbers. So let's see how far. Let's see how far we can go with it. Okay, write. I'm writing on the board. Write each of the following in exponential form. A, 12,650. B, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 0.1, 2, 3, 4, 5, 6, 7, 8. 5. C, 451. D, 625. 1, 2, 3. 1, 2, 3. So let's move this number. Okay, for E, 0.065. All right, let's move this number. Let's move this number. This number is in its numeric form, ordinary form, numeric or what? Ordinary form. Officially, it's what? Numeric what? Form. Officially, these numbers are in the what? Numeric. Okay? Officially. That's official name. Numeric form. So move this number from its numeric form to where? Exponential form. Oh yeah, let's do it fast. Let's move the numbers. And you are good to go. Simple. Just apply the decimal mode, know the direction. You move the decimal point and you are good to go. Remember, your target is to have a digit followed by a decimal point. Remember, you to have a digit that is not less than 1. From 1, you must have a first digit that must be 1, or that must be between 1 and 9.9 something. Then you now place a decimal point by the side. Then that will tell you the direction of the what? Decimal point. Then as it's moving, it will changing, the power will be changing until you get what the maximum number of decimal movement you need. Then also take note of the signs. If you're able to do that, you are good to go. Precious, you see go. Wow, that's good. This one. Let's solve this one, okay? Now remember our targets. Are we together? Are we together? Remember our target. Let's play with decimal movement first to know what will happen in the what is it called? The what is it called? The power. You know that initially we can express this. Are you aware that this is certain as saying 12,650 times 3 to the power 0? Are you aware? Are you aware? Good. Now the decimal point here is where? Here, right? So we start the movement. What about if we is it eating it up?
Yes.
Is it eating it up?
Yes.
Huh?
Yes, sir.
If you go like this, it's eating it up. So it's decreasing, right? That means each decimal movement we add one here, right?
Yes.
So that plus one, right? Plus one, right? Plus 3, plus 4. So we'll stop here. We are getting the form we are looking for. So the answer is what? That 4, we add it to this to this what? 0. So we have 1.265. Don't worry. Times this power what? 4. Are we together? Are we together? Of course. Because there's decimal point, and this 0 is you can do away with this 0. Hope you know. Then you can now have something like this: 1.265 times 3 to the power what? 4. Depending on how you are told to, you can leave the answer as 1.226 or 27 or 1.3, depending on what you are measuring. But you can leave it like this. Out together. So you have moved it to what? Decimal, sorry, exponential what form? Now here, let's work on this one. This one, there's this point here, right? We'll keep moving the decimal point until we get to this first digit. Are we together? Yes. And stop. You don't stop here. It becomes 55. Two of us. But it becomes 5.5. Are we together? So let's check the number of decimal movement and what should be. Basically, because of one to space, I may not start writing out everything here. But you know that what is there is 34 minus what? 0. Because this number times 34 0 is certain as what? This number. Because 34 0 is what? 1. If you know your laws of indices, anything raised to 0 is what? 1. So in that case, we have it at the back of our mind that this is certain as saying this number here times 34 what? 0. But in your paper, you can write it up the way I did this one. For space, I didn't want, or do I do it? Yes. All right, see what I mean. We have 0 point what? 8 zeros, right? Yes. 1, 2, 3, 4, 5, 6. So let's start our decimal movements. So here we have what? 1 minus 1. No, because you are increasing the what? The decimal place. True of us. Yes. So if you are increasing the decimal place, what you will reduce it from here, because that thing you are increasing, it is a balanced stuff. As you remove from here, what you remove from here, you are adding is. Sorry, as you are adding from here, you are adding here, you are removing from here, because you cannot get from the space. As you are adding from, because you are adding the decimal place, true of us, you are removing from here. So now let's go. Minus 1, right? Minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9. Stop here. That minus 9 added to this 0, it becomes minus 9, right? So the answer is what? 5.5 times 0 squared minus what? 9. Now, what about 451? Let's go. This can be expressed as. What's that? Is this one? It's 451. What do you write? So it's 451, sorry. Now, this can be expressed as 451 times 10 raised to power what? 0. So let's go. Remember there's a decimal point here already. Remember there's a decimal point here. This is invisible point. So you start removing, decreasing the decimal place, right? To get to this point, right? So if you decrease, you add 1 here, right? 1 plus 1, right? Plus 2, you stop. So we have 4 what?
0.51 times 10 raised to power 2.
2 or plus 2, the same thing, right?
Yes,
You stop here. That's for this one. What of this? This can also be expressed as 625 000 times 10 to the power what? 0. There is a decimal point here, invisible, right? So we start. Our target is to get to this place. For us to get to this place, we reduce the decimal places, right? And as we're reducing the decimal place, we are adding to the power, right? So here is what? Plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus 8 to stop. It becomes what? 6.25 times 10 to the power what? 8. Here encore 0.65. We can express it again in this form. We have what? 0.065 times 10 to the power what? 0. There are decimal points here. Our journey is to move the decimal. You see, sometimes the brain is saying nothing. The hand is right and nothing. Here is was 0.0 was 65. So it's 0.065. It's correct. So here, look up. The decimal point is here. Our target, what's that? Okay. Listen, please look up, please. The decimal point is here. Our target is to move it to this place. So we can have the first digit, right? To be followed by the decimal point. So if you want to move the decimal point to this place, we have to increase the decimal places, right? And as we are increasing the decimal places, we are reducing the power. True of us. So let's go. Here is what? Minus what? Minus what?
1.
Minus what? 2. 0 plus minus 2 is minus 2. So we have 6.5 times 3 to the power what? Minus 2. Does it make sense?
Yes, sir.
So with this simple step, you can move a number from exponential form to its numeric form. So if you digest this one, we check how to move number from numeric form to what? Exponential form. From exponential form to what? Numeric form. That's what here we move number from numeric form to what? Exponential form. So if you are done, let me clean the board. Can I? All right, thank you. Okay, let's look at this question. Put it down. Write each of the following in its usual numeric form. Okay. Write each. This one is even the words. This my color combination is funny. What's going on here? Okay. Can you see the board? Can you? All right. 4.1 times 8 to the power 6. B, 3.65 times 10 to the power minus 2. C, 5.13 times 10 to the power minus 6. Then D, 2.5 times 10 to the power 5. So we move these numbers are in the exponential form. So we move them to what? The numeric form. I'll give you a clue on what to do. It's very simple. Or can someone
3, 4, 5, 6.
uh-huh.
Then one that have the negative side. The point to start with the left hand side.
What you said is not about something informed that decision. That's what I want to hear. What inform? Okay.
I want to 10 in 6 places.
Then in 6 places. You are getting there, but there's something you're missing. I want to know give me the origin of that thing you're doing. That's what I want to. You are correct. Both of you are correct, but there's something. There's a target. There's a target. Now let me give it to any other person. You remember before you move, there was a target where you are moving to from numeric form to exponential form. There's a target here. See the target. The target here is to make it to be 3 to the power 0. The target is to turn this power to 0. That's the target. So if it is positive 6, you reduce the power to 0. If it is negative, you increase the power to 0. So this one that is 6, in attempt to reduce this power to 0, you have, this one is reduction now, you have a decimal movement, the opposite of reduction along the coefficients. Reduction, opposite of it is that you move to what? To the right. True of us? Reduction, you move to the right. But here it is minus. To get to 0, you increase the power. True of us? From minus 2 to 0 is increased, right? You increase by 2 times, right? So if you increase by 2 times, you do decimal movement, increases left. If you increase 2 times to get 0, you do decimal movement to the left. Okay. Increase to the left 2 times again. You get the answer. Now here is 3 to the power 6. In order to reduce this to 0, you reduce it by 6 times, right? That means you go decimal movement to the where? Right 6 times. You stop. You get the answer. Remember, the target is to reduce, is to make this to what? 0. It can be reduction depending on what. Here is 6. So you do reduction 6. Because it's reduction 6 times, the decimal movement will be opposite of reduction, which is what? Right side, right? 6 times. But here you are increasing 2 times to get 0. Decimal movement here will be to where? Increase left. Opposite is left. To left 2 times. So let's do what this thing I just explained now, so you appreciate it better. So here, these markers are not markering. Once it's not black, and anyway, there's some blue that write well anyway. I think it's for the company. Okay, let's use the black. Here now the power is what? 0, right? So it's 6. Our target is to reduce it to 0 by 6 times, right? So if that is the case, this is the decimal point, right? Reduction, which is, and then anything reduction is negative, right? Which that is the opposite here would what? To the what? Right. So we move the decimal point 6 times. 5. And each curve you make, you put 0 under it. True of us?
Yes.
Apart from this one that already has 1. 1, 2, 3. So we have something like this. 4.1. Let's start the movement. 1, 2, 3, 4, 5, 6. We'll stop here. We'll fill here with 0, right? 0, 0, 0, 0, 0. Times 0 to power what? 0. This 3.0 is 1. So everything would that become what? 4, 1, 0, 1, 2, 3, 4, 5. 0, 0, 0, 0. Which is 4.1 million. True of us?
Yes, sir.
What's next way go? Look at it now. So the first that got to your mind that you want to reduce, you want to make turn the power towards 0. To achieve that, it can be reduction, depending. It can be increment, depending. Now, if you look at this number now, let's look at this number. Is it clear?
Yes.
Let's look at this number now. This is 3.65. If you watch, for you to be able to turn this to 0, you have to add, increase 2 times, right? If you add 1 minus 1, add another 1, it becomes what? 0. So you will do decimal movement 2 times. What direction? To the left. So because it's left now, as you're writing this phrase, you create a space here, okay, that can accommodate so you can start from here. 3 point what? 3 point what? 65. Are we together?
Yes.
Let's leave the power for now. But we know that we move 2 times, right?
Yes.
So here it becomes what? 1, 2. 0 comes here, right? There should be 0 in front, right? These are the decimal points. Times 0 is for what? 0. Here it becomes 1. True of us. So we are left with what? 0.0365. Does it make sense?
Yes.
Now here, this one. Our target also is to turn this minus 6 towards 0. That means we have to do what? Increase by 6 times, right? And if we are increasing by 6 times, decimal movement to the left, right? Increasing to the left 6 times. So we can shift this 5.1 to somewhere here, so we can accommodate the what? The decimal point, the movement, right? So let's move 6 times to the left, right? So here is what? 1, 2, 3, 4, 5, 6. That's my point here. 0 will be here, right? So let's fill in that space with 0. We have 0, 0, 0, 0, 0 times 3 is power what? 0. Move that 10 power 0 is 1. So we now have what? 0 point what? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5, 4, 1, 3. That's the answer. Then this last one, the power is positive, right?
Yes.
5. So it's above 0. So you have to reduce it to what? 5 times to get what? 0. And if you are reducing it, movement will become opposite, which is what? Right. So if that is the case now, you have this becomes 2.5, right? Let's go. 5, right? 1, 2, 3, 4, 5. Decimal point will be, even though it's invisible. So you fill up here with 0, you have what? So there becomes what? 2, 0, 4 zeros, right? Right? So 250,000. Does it make sense?
Yes, sir.
So it's simple. Moving from exponential to numeric, and moving from numeric to what? Exponential. Very, very what? Simple. Once you understand the target on the coefficients. The direction it should go. Once you know all these things, you know it's very simple. Within few seconds, you just move any number to what the other form. It's simple. But be careful when you do your movement. That's where the error comes. If you're not careful, you may do the movement more than required. A question on this. We have succeeded in defining and explaining what experimentation means, and we are also going to the extent of showing how to move, how to convert a number from numeric to numeric form to the exponential form, and vice versa. The next sort of topic we look at is what? Operations in what? Exponential notation. Any question? Yes, theory. If it's do that this, yes. It means that you just punch your calculator and give me the answer. If it's essay, if you come as your work, give me that answer. I will know you just punch calculator. I'm complicated. You know, there are some of these sophisticated calculators you can even use to solve fractions. I hope you know. And they will even give you the answer in fraction. They will even give you the answer in common fraction. Are you aware? Yeah. So if a question appear like that in essay and you do that, I will know. Because where you show me where you do nonsense there. So you say, well, if you don't move this in where I will know. So that's the thing. That is if it appears, but if it appears as objective, just circle it. That's when you do not find now and be circling the option for me, no problem. But if it's essay, that means I want you to show. I'm not punching no. Show the steps you took. So the next thing we look at, we have 15 minutes to go. No, 10 minutes to go. No, 15 minutes to go. No, 10 minutes is when I will start adding up. So that I run up, that's the meaning. By maybe few minutes to 12:30. Not 12:30, I will start adding up. No. That's why I say tell me when it's 12, so that I will start adding up. By the time I finish packing my things at the 12:30. Alright, so let's look at operations in exponential notation. Of course, the operation we're talking about here is the basic mathematical operation like addition, subtraction, division, and what? Multiplication. Simple. So let's start with addition. What is the product of addition? What is the product of addition? Addition is just an operation. I hope you know. Addition is an operation. Are you aware? So that operation, remember you are basic fundamental operation in dispensing. If you carry out an operation, you compound. You have a product. True of us. Any operation will give you a product. True of us. Good. Now, addition is an operation. Mathematically, addition is an operation. So what is the product of that operation? Or let me not say product because it can be confusing. What will be the result? Let me use result better. Better is result, not product. Now, what is the result of operation called addition? Oh yeah. Who says some? Who says some? This girl will go far. This girl will go far. I said the result of the operation addition is what? Result of the operation subtraction is what? God bless you. Result of the operation multiplication is what? Have you seen why I removed that product? Because it can be confusing. Result of the operation division is what? Is what? No. On exactly here. Quotient. Who said quotient? Calculator. What's na phone when you here? Five thousand say no even you see that in that money is nothing. 5,000. All right, so we know this ones now. Please note those things. So the result of division is called what? Quotient. Result of multiplication is called what? Product. Result of addition is called what? Sum. Result of subtraction is called what? Difference. Okay, now, so we look at addition, subtraction, multiplication, and what? Division. Now let's start with addition. Let's assume you have these two numbers in their exponential form. Let me use an example here. 9.3 times 3 is 4 and what? 5. Okay? Sorry, times 3 is 4 and what? 3. Plus 3.1 times 3 is 4 and what? 2. Hello? Please, all together. Please, before you be able to do anything in this number, in this expression, before you can do anything, the first step is to ensure that the powers are equal. And the powers of the two numbers are what? Equal. Check if they are equal. If they are equal, you do your thing. If they are equal, see what you do. If they are equal, you bring that one by the side. Then add the coefficients. Just like 9s squared plus 4s squared. What is it? You bring that x by the side, right? S squared, right? Add 9 and what? 4. The answer is what? If you understand this, you are good to go. Remember the relationship between x squared and 9 here is multiplication. Hope you know. The operation holding x and 9 here is what? Multiplication. The same way, the operation holding this 3 to power minus 3 to power 3 and 9.3 is what? Multiplication. So you can solve it through this way. But the point now is this: to make these two equal. And the only way you can make it equal is to manipulate the decimal movements along the coefficients. Simple. If you manipulate decimal movement along the coefficient to make them equal, you are good to go. If you understood what we did last, you can do that. Now tell me, what movement can you make here?
You're right.
The only thing you are doing here is just to manipulate this movement to get. You can move this to be 3 to the power 3, or you can make this to be what? 3 to the power 2. Either way, will be the same answer. Ask him how. That's why you are here. I'll show you how now. Now let's do this one first. Let's make this 3 to become 2. Solve and keep the answer, and make 2 to become 3. Solve and keep the answer and see whether it's true or not. Are we together? Let's try it.
So,
Yes.
without change, can we make two of those the same?
Which one?
Like that's raised to power 3. Can we make it to the same like both of them?
If you make it so, you are converting to numeric form, but that's not what. If you make it to zero, you are converting to what?
Or can you make it to 0 and after the whole
We now convert it back.
Don't convert to numeric form, then come back again. Work it here as it is. Don't move to numeric form, then add and come back again. Don't do it for me. And I know what you are saying, but don't take that step. I want you to work on it here as it is hot. Are we together?
Yes, sir.
But if you can move it to 0, you can do this thing simple. This one is even faster, self. Yes, it's faster. Because you get a TPI here upload 0. So trying to bring it to 0, why not make it 2 and stop and add and get your answer? Or is it this 9 square is this 9? This thing is what you are afraid of. Common this here is x2, right? X2 equal to you bring it out and add up. The same thing. If you make this one 3 power 2, common this in there is what? 3 power 2. You bring it out this 2 and add 9.3 and 3.1 and get your answer. See what happens. See it here. Let me do it so that I don't talk too much on that. Now let's move. Let's first move this to this, right? Good. Now this is 9.3 times 3 power what? 3. You want to move this to 3 power 2. How do we do that? How do we accomplish that? We reduce this to what? By 1. 3 of us. We reduce 3 to by 1. You get 2. So as we are reducing it by 1, there will be decimal movement to what direction?
Right.
To the right, right? Opposite, right? As you are reducing it, decimal movement will be 1 to the right. 3 of us. So you now have something like this. So this will move from here, right? And stop here, right? So we have 93, right? Or just leave it at 93. Times 3 power what? Is it clear? You have achieved that. They now have the same power. You cannot add up. So you now do 93 times 3 power what? 2 plus what? 3.1 times 3 power what? 2. You can bring that 3 power 2. You have what? 93 plus what? 0.1, right? Times what? This and this is what? 96.1 times 3 power what? 2. Is it the best way it can be?
No.
Make it to bring it to this stable form. So you move here, right? It becomes 9.61. Because you have moved decimal movement to the left, 1 to the left. To the left. As you move to the left, you are decreasing the what? You are decreasing the what? Decimal place, right? So you not increase the power by 1. So here it becomes what? It's 9.61 times 6 power what? 3. Does it make sense?
Yes, sir.
This thing is built. If you are missing out on what we did, they built on top of each other. If you miss out in the first one, what I'm saying will look like as if I'm telling folk tales. But if you are following step by step, you see that it's there. Can we move this to 3?
Yes.
Let's try it. Let's move that thing to 3. I will leave this one so we can compare. Let's move 3.1 times 8 power 2 to what? 3 power 3. Here we have 3.1 times what? 3 power 2. Let's move it. Our target is to move this to 3. So we will increase it. We increase the power by 1, right? So plus 1, right? So what is the effect here? Decimal movement to the left. 1